Imagine for a moment that there is something invisible around us, something that makes up 85% of all matter in the universe, but that we can never see or touch. Sounds like science fiction, doesn't it? But this is our reality. Dark matter is one of the greatest enigmas of modern science, and today I'm going to tell you about a revolutionary discovery that may finally help us unravel this cosmic mystery. And here's a fact that will blow your mind. While you're watching this video, trillions of dark matter particles are passing through your body at this very moment. They pass through you, through the walls of your house, through the entire Earth, as if nothing existed. It's as if we lived in a phantom universe parallel to our own. Scientists have just proposed an absolutely fascinating idea. They believe that dark matter clusters may be functioning as true stellar lampshades, positioning themselves between Earth and distant stars, dimming their brightness in an almost imperceptible way. That's right, what you heard, lampshades in space made of invisible matter. Let's start with the basics. Dark matter is like a cosmic ghost. It's everywhere, influencing the structure of the universe through gravity, but remains completely invisible to our eyes and instruments. For decades, scientists have been racking their brains trying to understand what exactly it's made of. It's like trying to solve a puzzle where you know pieces are missing, but you can't see them. To give you an idea of the magnitude of this mystery, if we could see dark matter, the night sky would be completely different. Imagine looking up and seeing gigantic invisible structures stretching for billions of light years, connecting galaxies like a gigantic cosmic web. It would be an absolutely surreal spectacle. Now, a team of researchers is focusing on something called MACHOs, which stands for Massive Compact Halo Objects. The crucial difference between MACHOs and other dark matter candidates is that they are made of the same type of matter that forms you, me, the stars, and the planets. It's baryonic matter, that is, normal matter that can interact with light, even if very weakly. Melissa Diamond from Queen's University in Canada explains it in a brilliant way. She says that although we usually think that dark matter is completely transparent and invisible, the truth is that it can interact with light in a very subtle way. It's as if it were a ghost that sometimes leaves footprints. Here's where things get really interesting. These dark matter clusters can form large clouds in space, and when one of these clouds passes between Earth and a distant star, it can partially block the star's light, exactly like a lampshade does with a lamp's light. The star doesn't disappear completely, but becomes a little dimmer temporarily. Think of it as an eclipse, but in reverse. Instead of a completely opaque object blocking all the light, we have something semi-transparent that only dims the brightness. It's as if the universe were using a cosmic dimmer. But here's the most impressive detail. We're talking about a dimming so subtle that it would be impossible to detect with the naked eye. It's a variation of less than 1% in the star's luminosity. To detect this, we need extremely precise instruments and sophisticated statistical analyses of thousands of stars simultaneously. But here's the problem. When dark matter clusters become very large and diffuse, they lose this ability to act as lenses. That's where the lampshade effect comes in. Even if the cluster is too diffuse to amplify light, it can still partially block it. The most incredible thing is that we can use data that already exists. Astronomical surveys like the optical gravitational lensing experiment already monitor thousands of stars looking for brightness increases. The same data can be reused to look for brightness decreases caused by dark matter lampshades. It's like discovering that you can use the same metal detector to look for both gold coins and silver coins. The tool is the same, but you're looking for different signals. This means that years of astronomical observations may contain evidence of dark matter that we haven't discovered yet. Of course, it's not that simple. The big challenge is distinguishing the dimming caused by dark matter from the dimming caused by normal objects like planets, other stars, or gas clouds. It's like trying to identify the ghost in a house full of people moving around. But scientists have a trick up their sleeve. They can compare how the star's brightness changes over time. A planet, for example, would cause a specific type of dimming because it's completely opaque. A dark matter cloud, being semi-transparent, would create a different pattern of brightness decrease. The beauty of this technique is that it works both to confirm and to rule out theories. If we observe the lampshade effect, this will give us valuable clues about what dark matter can be. If we don't observe it, that's also important because it shows us what it cannot be. It's a situation where we can't lose. Diamond was surprised to discover that surveys originally designed to detect brightness increases are also sensitive to brightness decreases. It's like discovering that the same instrument you use to measure mountains can also measure valleys. This discovery could revolutionize our understanding of the cosmos. Just imagine, after decades searching for something we can't see, maybe the answer is in the data we already have, waiting to be discovered. It's like having the treasure key all along without knowing it. And there's one more fascinating thing. If this technique works, it will not only help us detect dark matter, but it could also give us information about its internal structure, its density, and even how it behaves over time. It's like finally being able to take a picture of a ghost that has been haunting us for decades. The universe is full of mysteries, and dark matter is one of the biggest. But with innovative techniques like these stellar lampshades, we're getting closer and closer to unraveling the secrets of the cosmos. Who knows? Soon we might finally understand what this mysterious substance that shaped the universe as we know it is made of. If you were as fascinated by this cosmic mystery as I was, don't forget to like the video. This helps me a lot to continue bringing content about the greatest enigmas of science. Subscribe to the channel so you don't miss any incredible discoveries of the universe. Until next time, Cosmos Explorers.